Hello, welcome to our YouTube channel where we are providing mathematics to people that are writing their grade 12 exams and the 9 here in Zambia. And we are making sure that we provide all the lessons that one may need to pass their exams without difficulties. So this is one of the lessons that I'm presenting under probability, and we are going to, I think all these questions have been collected from past exam papers. So I want to see how we can handle such a question. So let's look at the first question. There are 6 girls and 4 boys in a drama club. Two members are chosen at random to represent the club at a meeting. What is the probability that both members are boys or one member is a girl? Okay? So, such questions can even be handled without a tree diagram. If you want, you can do a tree diagram to help you simplify the work, but even without. So, we are saying for the first one, without a tree diagram, if both members are boys, then it means, remember that we are choosing from 4 boys and 6 girls. All right? So if both members are boys, I hope you have seen the question. If both members are boys, the first boy, to choose the first boy, we are going to get 4. Both members are boys. The first one is a boy and the second one is a boy. This is what we have. You remember was it a third lesson or so where we talked about independent and mutually exclusive events? So if the first member is a boy, we're going to have 4 over the total, which is what? 10. There are 4 boys selected out of 10, which is the total. Then to have another boy, the second boy, we are going to say the first one that was selected is a boy. So to select the second one, a boy also, it means we are selecting now from 3 boys over 9, because we have a boy already selected. So we are remaining with 3 boys, and the total number has also reduced for boys from 4 to 3. So the probability is going to be, if you want, we can simplify this part. It's important when you're dealing with the fraction. We can even simplify the first one so that we can have 2 over 5. The second one, we can have 1 over 3. So that when you multiply this, you have 2 over 15. Then a situation where we are going to have, what are we going to have? 12 over what? 12 over 90. Okay? Then we begin to simplify this one. We say 6 here, 2. 6 into 9, it's 1. Remainder, 3. 6 into 30, 5. So we can even simplify at that point. So this is the probability. Remember, we have not drawn any tree diagram here. Okay? So we are saying this is what we can get for this first one. I hope you have seen already this part. You can get back to see the question in full. Let me have enough space. So, one member is a girl. One member is a girl. One member must be a girl. How do we look at this one? A girl should be there. So, in other words, we are saying one member should be a girl. So, we are saying one member is a girl. It means the other one is a boy. So, here, we are looking at a probability of having a girl and a boy, or the probability of a boy and a girl. A girl must be there. because we've been told that one member is a girl. So we can either have this or this one. So that is what we're expecting here. And now, I want you to look at this question and pay attention. I've not drawn a tree diagram, but I'll still come to where we can use a tree diagram and we should be able to get. So remember this is what we have here. And we are saying we have 6 girls and 4 boys. So, for this one, if we have the first one is a girl, we are going to have 6 over 10 multiplied by the second one is a boy. Please follow me. The second one is a boy. So what we are saying is that the total number has reduced because one girl has been selected here. So the total number has reduced from 10 to 9. But the number of boys remains intact because the first one that was selected is a girl. So we have 4 over 9. Plus, if the first one to be selected is a boy, the number of boys is still 4 over 10 multiplied by the number. Now the second one is a girl. The girls are still 6, but then the total number in the group or in the club has reduced to that. So now, this is what we have to work with. This is what we have to work with. So we can say this is what? 24 over 90 plus 24 over 90. When you add, you have 40 what? 48 over 90. Okay. Let's see. 6 here. 6, it's 8. 6, it's 8. 6 into 48, it's 8 times. Yeah. Okay. I'm using 6, then 6 into 9, it's 1. Remainder, 3. 6 into, we have 15. So this is the probability, which is going to be 8 over 15. The other one we got what? You remember what we got on the other one? It was 2 over 15. So this is what we are going to get. Now let us look at the same question using a tree diagram, and you are going to see which one is easier for you. Okay? We're going to see which one is easier for you. So we are saying for girls, for the girl to be selected, if the first one that was selected is a girl, it's 6 over 10. For boys, it's 4 over 10. This is boy. Now, since there are 2 people that were selected, this was the first selection. So we come to the second one. We have girl and boy. Girl and boy. So, if the second one that was selected is a girl, the first one here was a girl. So if the second one is a girl, so it means the number of girls has reduced from 6 to 5, and the total number has also reduced from 10 to. But then for boys, there are still 4 over 9. The same thing here. If the first one was selected is a boy, then the second one, it will be 3 over 9. But then for girls, there are still 6 over 9. So this is girl, 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 boy, and then boy, girl, then boy, boy. Okay? So if they said, find the probability of having members of the same sex without specifying whether they are boys or girls, members of the same sex, just we are going to add girl, girl, what is here, plus this one. All right? That's what, because they just said members of the same sex. So now, if they said boy, like this one now, if you're using a tree diagram, boy, boy, you just multiply this and that. Okay? You just multiply this and that, and you are going to get what? 6 over multiplied by over we're talking about boys, boy, it will be 4, which is this one, boy. It's 4 over 10 multiplied by 3 over 9. Okay? This is the same thing. This is going to be 1 over 3. This is going to be what? 2 over 5. And when you multiply these, they'll give you 2 over 15, which is exactly the same thing that we got there. And if you want to solve the second one using this tree diagram, if you want to solve the second one using this tree diagram, this one that talks about one member is a girl. One member is a girl, okay? One member is a girl, we have this case here. Here we have a girl, even this one we have a girl. So it will still be probability of the same thing that we are talking about there. Probability of boy, girl. Now, the first one, girl, and the second one is a boy. This is exactly, I'm just running you through what we already did, but using a tree diagram. 6 over 10 multiplied by 4 over 9. Plus, what do we have here? Here we have boy, which is 4 over 10 multiplied by 6 over 9. This one. Then this. So, we can simplify this one here as 3 over 5. Okay? We can also, this one, we can leave it as it is. Plus, we can also simplify this one here as 2 over 5 multiplied by 2 over 3. Okay? I want to go further. This one, we can have 1 here, and here we can have what? 3. Okay? So the first one, we have 1 over 5 multiplied by 4 over 3. Okay? Then, this other part here, what do we have? We have, okay, this has been simplified, so we have 4 over 15. And this side, what do we have? We have 4 over 15. 4 over 15. When you simplify this, what do you get? You get 8 over 15. Exactly the same question that we got even when we went the other way. Okay? Even without a tree diagram. You should be able to get the same answer. Should be able to get the same answer. Alright? So, let's look at the second one. Let's look at the second one. So, a box contains 10 identical cards. These identical cards have numbers, number 1 up to 10. These identical cards have got numbers, number 1 up to 10. So, if 2 cards are drawn at random from the box, one after the other, of course, without replacement, what is the probability that both cards are prime numbers? Both cards are prime numbers. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Both numbers that you are picking are prime numbers. The probability of picking the first one, the probability of selecting, if the first one is a prime number, first of all we need to look at how many prime numbers do we have here. How many prime numbers do we have here? Prime numbers that we have here, we have this one, this, there are 4. Okay? So if we are going to have the probability of having the prime number, the first one is a prime number, even the second one is a prime number. Okay? The first one, what is the probability of getting the first prime number? We are looking at 1, 2, 3, 4. How many are there? They are 4 out of the total in the box, which is there are 10. Okay? Then the second, the probability of picking the second. Take, for instance, one of them has been removed. If it was these two, just an example. Just an example. So it means now, how many prime numbers have remained within the box? There are 3. And also the total number has reduced from 10 to 9. Okay? So this is what we are going to have. And I have kept on saying, you can simplify this to 2 over 5, even this to 1 over 3. Then you have 2 over 15 as your answer here for the first question. Okay? For the first question. Then, at least, what is this question? At least, one, I think this is supposed to be 1, at least one odd number. At least one odd number. At least one odd number. Okay? Now, at least one odd number. At least one odd number. So, for what I understand this question to be, I'm looking at it now where we are solving it without a tree diagram. For what I understand this question to be, okay? We can have a situation where, remember we can have a situation where an odd number, let's say odd number, then not an odd number. Okay, so at least one odd number. It means an odd number it's a must, it must be there. So at least there should be one odd number. Alright? So for what we are expecting here, I said take it that this is an odd number and this is not an odd number. We can have a situation where we are going to have the probability where we're going to have an odd number and the second one is not an odd number. The first one is an odd number and the second one is not an odd number. We can also have a situation where the first one is not an odd number. It's not an odd number. Then the second one is an odd number. Remember, we are talking about the word at least. So we can also have a situation where we have both of them are odd numbers. Because we are only saying the minimum of odd numbers, we should have 1. So we can have even more than 1. So where we have both odd numbers also does qualify. So those are the 3 probabilities that we have to work with, if you are getting me. Okay? If you are getting me. So, allow me. So, this one, the first one, I hope you are following me. The first one is an odd number. Let me put back the 2. The first one is an odd number. How many odd numbers do we have here? We have 1, 3, 5, 7, 9. We need to know what an odd number is. An odd number is a number that is not divisible by 2. So these are odd numbers. It's important to know what numbers we're talking about. Prime numbers, they are numbers that only have 2 factors. Okay? So we are saying, what is the probability that we are going to have an odd number? So, the probability of having an odd number, for the first one, it is what? Those that are not odd numbers. The probability of having an odd number is what? 5 over, the probability of not having an odd number is 5 over, okay. So if we are saying this is what you are going to get, that you can have the probability of where you have the first one is an odd number and then the other one is not. Okay? The first one is an odd number, then the other one is not. Are we able to see? Let me check if we're able to see. Okay, it's clear. So now, what I was saying, if the first one, we're saying the first one is an odd number. There are 5 out of 10. Then this, for a probability of getting, if the second one is not an odd number, how many do we have? Those that are not odd numbers. There are 5. 1, 2, 3, 4, 5. So we have 5, but then the total number has reduced from 10 because 1 was it. Okay? Then we go back to normal. I mean, if we go back again, we say, if the first one to be picked is not an odd number, again it will be now, if the first one is this one, then odd number, it will be 5/9. Then the probability of picking, now the odd, both of them, the probability of picking now, both of them are odd numbers. Probability of picking both of them are odd numbers. Okay? What do we have? The first one is going to be 5/10. Then the second one will be 4, because the odd numbers have reduced now. 1 was, and again we're going back for the odd numbers. So it will be 4/9. So we simplify now these. Okay, we simplify these. What do we get? We have 25/90 plus 25/90, okay, plus 20/90. All right, so we simplify. You can add all these now. This is 50, 70. So we have 70/90, and this gives us 7/9. This gives us 7/9. All right. Now I want to try and see if it can work using a tree diagram. I want to just see if it can work using a tree diagram. Okay. These are independent events. So, okay. So, for the first one, I think it was for the first one, if we are looking at even number, I mean, the first one was talking about prime numbers, eh? The first one was talking about prime numbers. That one is straightforward. Now I want to look at this one that is an odd number. So we're saying if the first one is an odd number, then the second one is not. I mean, the first one, this is the first draw. So we have the odd numbers are 5/10. Then those that are not, it's what? Also 5/10. Then if the second one is going to be an odd number also, the second one is going to be an odd number also, so it reduces from 5 to 4. So we have 4/9. The total number also reduces, like I was explaining. Then for those that are not odd numbers, they are still at 5/9. Okay? The same thing will happen here. Odd numbers. If the first one that was drawn was not an odd number, and then the second draw is also going to be for the odd numbers. If the second one is also not an odd number, then we are going to have 4/9. Then for odd numbers, they are still at 5/9. So now this one is for odd and odd number, and this one is for odd number and not, and this one is for not, but the second one is an odd number. So then this one is not both. So again, it goes back. To find our answer, what do we need? We need this one, the probability for this one, and this one. The three of them, I should think these are the same ones. Okay? This one is this part. Is this part, as you can see. 5 over 10 multiplied by 4 over 9. That is that part. Then the second one, where we're talking about, the first one is an odd number, then the second one is not. It's this one. You've seen. This one. 5 over 10 multiplied by 5 over 9. This one here. Okay? Then this one is where we're saying the first one is not an odd number, which is this one, and the second one is an odd number. That is that one. Then you simplify. So you should be able to work out all the at least one is an odd number. So this is what we are expected to do. All right? So thank you so much. I'm going to give you simple questions from the past exam papers just for you to work them out around the same examples. Okay? So the first question that I'm going to give you is I think was in 2014. In 2014, this question here, B. Let's do question B. At least one is a boy. So you've seen the concept is the same as this other part I was dealing with for at least one odd number. Then let's also look at this one. This question B, the B part. All these are past exam papers. Otherwise, thank you very much. Thank you so much for watching. Make sure you hit that red button down there, subscribe button. Subscribe to this channel so that you benefit on all the videos that we're uploading. So thank you so much. This topic I think has about 8 or so lessons. Make sure you watch all of them. Okay, so you won't have challenges with most of the exams.